right, related to Algebra 1's upcoming exponential test, I'm going to go over the Unit 3 test review packet. You can use this at home to look back at anything that we've discussed in class in preparation for your test this week. You'll be taking a test either on Wednesday or Thursday, depending on what hour you have. How can you tell the difference between a linear and an exponential relationship? In a linear relationship, we have something that is added or subtracted at a constant rate. In a linear relationship, something is added or subtracted at a constant rate. That's known as our slope. In our exponential relationships, we have something that's multiplied or divided by the same amount. In an exponential relationship, something is multiplied or divided from one y value to the next. Is multiplied or divided to get from one y value to the next. When we're in exponentials, the difference between a growth factor and a growth rate. The growth rate is how something increases, like 3% or 25%. How something increases. The growth factor is 1 plus the rate as a decimal. And we put that growth factor into our equation. In our equation, y equals a times b to the x. B is our growth or decay factor. We get that number by adding 1 or 100% to our growth rate. The difference between decay factors and decay rate, same idea as number 2. The decay rate is how something is decreasing. The decay factor is 1 minus that rate as a decimal. The decay factor is 1 minus, or 100% minus the rate as a percentage. 1 minus the rate as a decimal. Now I'm also going to go over here and say that's the growth, or it could be the decay factor, depending. So the structure we've been using to write equations. Next set, write each expression in exponential form. That just means talk about the repeated multiplication. This would be 4 to the 4th power. In part B, looking at 7 to the 1, 2, 3, 4, 5, 6. Remember, exponential form is helping us to shorten up repeated multiplication. Same thing here. Write the product as a power, 2 to the 4th. 8 to the 1, 2, 3, 4, 5, 6, 7. 8 to the 7th. M to the 1, 2, 3, 6. Now, using our calculators, we can evaluate each of these expressions. 2 to the 4th power is 16. 3 to the 3rd power is 27. 9 squared is 81. And 10 to the 0 power, anything to the 0 power is 1. Don't forget, any number to the 0 power is 1. I'm going to go on. One of the advantages of having a video of this is if I'm moving too fast as I go over it, you can look back at it later. Number 12 shows a linear relationship. It's actually asking about growth. This is linear growth. 13 shows that nice curve, starts out slow, goes up faster, exponential growth. 14, same idea, starts out low, speeds up, that's going to be exponential growth. That idea that the multiplier is making things larger and larger. Do the table show exponential or linear growth? When I look down here, I'm just looking for change. And what I notice right away is these are all adding 5 all the way down. Keep adding 5. This is going to show linear growth. I look to see if something's added. If I add 25 cents, if I add, no, that's not what I have. This one looks like it's doubling. 25 cents times 2 is 50. 50 cents times 2 is $1. You got it. It's doubling. That's the definition of our exponential growth. Something multiplied through. Last but not least, let's see, anything added? That would be plus 5, plus 5. It looks like this is a linear as well. Adding 5, carries all the way down. Linear growth. Simplifying some of our exponential products. This is the product rule. This is going to mean that I'm going to add the exponents. I have the same base of m. Number 18 will wind up being m to the 7th. Number 19, I've got the same base all the way across. 5 plus 4 plus 2 is going to leave me with c to the 11th. Number 20, I'm going to multiply 5 times my coefficient of z here, which is just 5. And then I have z to the 3rd plus z to the 5th, which is going to leave me with z to the 8th. In 21, I'm going to multiply my 3 by 8 together. Let me just kind of group these up. 3 and 8 can get multiplied together. X and x can get multiplied together. Y squared and y to the 4th can get multiplied together. It's going to give me 24x squared y to the 6th. 24x squared y to the 6th. Now, when we get down to number 22 and 23, we did these together in class. At least in my room we did. In 22, once we had it graphed, we said that once we set up our scale and had it graphed, we knew this was exponential by the way it acted. We came back and said it starts at 1. Y-intercept is when x is equal to 0. The growth factor was how it changed. We were able to write this equation. Number 23, same idea going on. The only thing in my 23 is that I hadn't graphed them. 0 and 1 is going to be down here. 1 and 5, I'm still real low. 2 and 25, I start seeing this increase. 3 and 125, so I'm up here, that nice exponential curve. And it started out at 1 when x is 0. We figured out that this was being multiplied by 5. Y is equal to 1 times 5 to the x power. I'm going to move on to number 24. You decide to start a garden at your house and plant black-eyed Susans. The next summer, you noticed that the flowers had reproduced significantly, and you wrote the following equation. N, or the number of flowers, is equal to 5 times 4 to the t, where t is the amount of time. We could write that as 5 times 4 to the x and have the same y equals relationship. No big deal that I used n and t. According to this, how many flowers did I plant in the first year? Y is equal to 5 times 4 to the 1 would be 20. The growth factor for the black-eyed Susans is the B value. It's 4, so they're quadrupling every year. How many flowers will there be in the garden after 4 years? 5 times 4 to the 4th. I can put that exponent on the inside or outside. I just noticed that I'd put it there. I've got 1,280. And in how many years will there be over 5,000 plants in the garden? Well, back here at 4 years, I had 12,080. I'm wondering what it would be at 5. I'm just going to try 4 to the 5th power. Let's see here. That's putting me up at 5,120. So actually, I was right on top of the answer. Nearly, nope, just over. Oh no, nearly 5 years, because at 5 years we have nearly 5 years. And you could go on to say at 5 years it's exactly 5,120. Number 25, the table shows how a population of whales increases over several years. Is the population linear or exponential? As I glance at this, I see an adding 5 each time. That's going to make it a linear. Starting population is when x is 0. I've got 50 whales. And equations for a linear relationship is our mx plus b. Y is equal to that change, that slope or constant rate is 5 times x plus the 50 whales I started with. Y equals 5x plus 50. Moving on, I think I'm going to get this all in one video. I'm going to rewrite a to the 9th over a to the 4th as a division problem. Proper fraction division as we see here in high school. Oopsie. That means I'm going to subtract my exponents and get a to the 5th. One of the ways you can think about this, where is there more a's in the top? How many more? 5 puts it to the 5th power, a to the 5th. Number 28, using that same idea, it's called the quotient rule, 13 to the 21 minus 7. How many, where are there more 13s? Up top, how many? That would take me to 13 to the 14th power. I'm comfortable with you leaving it there. 10 to the 7 minus 3. Where is there more 10s? Up top, how many more? 4, 10 to the 4th power. And I'm going to rewrite 10, a to the 12th over 5, a to the 3rd. I'm going to simplify my numerical part first. 10 divided by 5 is going to give me 2. Where do I have more a's? In the numerator, how many more? 9. A to the 12 minus 3 leaves me with 9. In each of these, in order to get the growth factor, I know these are exponential. I'm going to divide up and see what that number is. 132.71 divided by 55.296 is giving me, it's undoing and telling me I multiplied by about 2.4. 55.296 divided by 23.04. Again, I'm seeing this times 2.4. I'm going to keep looking up just to make sure. 23.04 divided by 9.6. I'm dividing up to find that every time I multiplied by 2.4. The growth factor in this case is 2.4. I'm going to do the same thing on part B. Part B, how do I get from one to the next? 18.9 divided by 10.5 is putting me at a 1.8. I must have multiplied by 1.8. 10.5 divided by 5.83. There's my 1.8 again. And I'm going to assume that the rest of the divisions are going to result in 1.8. Growth factors related to growth rates. As a decimal, 25% is 0.25. When I add it to 1, I have a growth factor of 1.25. As a decimal, 7% is 0.07. When I add it to 1, I have 1.07. Must have added 0.42. That puts me at 42% growth here. 2.5 means I must have added 1.5. That's 150%. I must have added 0.2. That's 20%. And if I'm adding a growth rate of 0.50, that's going to put me at a 1.50 for my factor. Moving on, getting close. Growth factor in 32A is 1.07. Remember, this is 0.07 as a decimal. Add it to 1. In order to find out after 6 years, I'm going to do 750 times 1.07 to the 6th. 750 times 1.07 to the 6th power is going to give me $1,125.55. 33, I'm investing 50 at a growth rate of 3%. Growth factor is 1.03. After 10 years, if I start at 50, multiply by 1.03 to the 10th, I'm going to wind up with $67.20. I don't know if I could wait 10 years for that much. Power rule. I'm going to multiply my exponents together. X to the 12th. 2 to the 2 times 8 puts me at 2 to the 16th. Y to the 18 times 3 puts me at y to the, 54th. Z to the 5 times 6 puts me at z to the 30th. The equation for the table in number 38, first of all, I know the starting value is 20. And actually, knowing that it starts at 20 makes me think that C is the correct answer. I'm going to just check that my growth factor is that 1.3 that I see in the equation. 57.122 divided by 43.94. Yep, when I divided that, I'm seeing that's 1.3. I'm just going to check another one. 43.94 divided by 33.8. Sure is. Letter C. There you go. Test will be Wednesday or Thursday, depending on your hour.